This is Odum Maths. Now today I want us to look at a very simple topic in mathematics, that is indices. And this has got a brother which is logarithm. So today I am going to concentrate on indices. Then in our next lesson we'll look at logarithm and some properties. Okay. Now when we talk of indices, for example, if I have a to the power b, we call this b the exponents. The exponents or index or the power. So b is either the exponents, index or the power. Then the a is the base. So when you see a number or a variable to a certain power, the variable itself is the base, and then the power becomes either exponent, index or the power. So the plural form of index is the indices. Okay, so now giving 5 to the power 2 to multiply 5 to the power 3. Okay, somebody can write this as 5 times 5, and this as, so times 5 times 5 times 5. Okay, so then we can count the number of 5s here. So that is, we have 2 5s here, and then this side we have 3 5s. So when you add all together, we are going to get 5 of the 5s. So we have 1, 2, 3, 4, 5. So 5 of itself. Okay. Now somebody can also say 5 to the power 2 times 5 to the power 3. Instead of counting, expanding and counting everything. And this is also going to give us the same thing. So what the person can say is, okay, why don't the person add the powers? So that is also going to be 5 to the power 2 plus 3. Okay, so in this sense, when you are given a number to multiply and they are of the same base, so what we are going to do is just to add the powers. So this brings us to the first rule or the first law of indices, which states that a to the power certain m times a to the power n becomes a to the power m plus n. So when they are of the same base multiplying, we add powers. So this is the first law of indices, or first rule of indices. Okay. Now let's look at this also. So 3 to the power 4 to be divided by 3 to the power 2. Okay, so we can rewrite this as 3 times 3 times 3 times 3 divided by 3 times 3. Okay, so simple cancellation. This will take care of this one. This also take care of this one. So we have 2 of the 3's here remaining here. So the answer to this becomes 3 times 3, and per what we did earlier, we can add the powers. So that is going to be 3 to the power 1 plus 1, which is 2. Okay. Now somebody can also say that, okay, when you have 3 to the power 4 divided by 3 to the power 2, okay, looking at this, you have 4 of the 3's and 2 of the 3's, but this is giving us to the power 2, means that when you have 4 and 2 and you are getting 2 as an answer, then it means maybe subtraction happens or sometimes division happens. So let's see. So instead of saying, we can say that, okay, this is 3 to the power 4 divided by 3 to the power 2, and this is going to be 3 to the power 4 minus 2, because 4 minus 2 will give us 2. So we have 3 to the power 2. Okay. Now this also brings us to the second law of indices. That is, I am making it second. Second law of indices, which states that when 2 numbers are divided and they are of the same number, or if they are variables, they are of the same variable, we don't worry yourself, just subtract the powers. So it states a to the power m divided by a to the power n becomes a to the power m minus n. Okay, now let's move forward. Once again, let's look at this also. So when you have 5 to the power 2 all to the power 3, how do we write this, or how many ways, or in what way can we write this also? So we can say that we can write this is 5 to the power 2 appearing or multiplying itself 3 times, or 3 of 5 to the power 2. So that is 5 to the power 2 times 5 to the power 2 times 5 to the power 2. Okay, let's see what happens when we have this. Now, per what we learned earlier, we said when they are multiplying and they are of the same base, we add powers. So this is going to be 5 to the power 6. That is 2 plus 2 plus 2, which is 5 to the power 6. Okay. Now, if this is giving us 6 and it is 2 and 3, then it means something of multiplication happens. So we can also say 5 to the power 2 is the same as, all to the power 3 is the same as just writing and then multiplying powers. So that is 2 times 3, and this is 5 to the power 6. Okay. Now, this also brings us to the third rule or law, which says that a to a certain power m or to another power n is the same as a to the power m times n. Now let's look at some few examples and then we continue. Now let's look at these few examples. Express the following as single powers. So a 5 to the power 3 times 5 to the power 4, b 7 to the power 5 times 7, then c 8 to the power 7 over 8 to the power 5, and then d 243 over 27. Okay, so let's start from the a. So the first one, 5 to the power 3 times 5 to the power 4 becomes 5 to the power 3 plus 4, and that is 5 to the power 7. Okay, then the second one, b 7 to the power 5 times 7 also becomes 7 to the power 5 plus 1. That is, we are using the first rule or law of indices. So this is 7 to the power 6. And then the third one, that is c, 8 to the power 7 divided by 8 to the power 5 also becomes 8 to the power 7 minus 5, which is 8 to the power 2. Okay. Now, the d, 243 divided by 27. Now, 243 is the same as 3 to the power 5. And then 27 is also 3 to the power 3. So this is like 3 to the power 5 divided by 3 to the power 3. And the second law applies. So that is 3 to the power 5 minus 3, which is 3 to the power 2. Okay, so that becomes the answer to this. Now let's look at negative indices. There are about 3 properties to those indices. So, example, the first one, let's say we have a to the power 3 divided by a to the power 5. Okay, so we can say that this is a times a times a divided by a times a times a times a times a. 1, 2, 3, 4, 5. Okay, so this and this will take care of themselves. So here we have 1. So 1 over, this is going to be a to the power 2. Okay, so we can also say that a to the power 3 divided by a to the power 5 is the same as a to the power 3 minus 5. And 3 minus 5 is going to be giving us negative number. So that is a to the power negative 2. So it means that 1 over a to the power 2 is the same as a to the power negative 2. And we can also say that 1 over a is the same as a to the power negative 1, because this is having a power 1. So that is the first property. Okay, to this. Let's look at the second one. Now, once again, let's look at a to the power negative 4. So we can say that when a variable is having a negative power, that variable becomes a denominator. So let's see. So we can say this is 1 over a to the power 4. And we can write this as 1 over a times 1 over a times 1 over a times 1 over a. Okay, so it means that when a is having a negative power n, then this is the same as 1 over a to the power n. Okay, and we should bear in mind that a shouldn't be equal to 0. A should not be equal to 0. Okay, and this is the second one. So now let's look at the last of the properties. That is, to bracket, a over b to the power negative n. And we are told that this is the same as b over a to the power positive n. So let's see whether this is true. Okay, so I'm going to take this side and try to see, manipulate and get this one. So we said earlier that a to the negative n is the same as 1 over a to the n. I hope this is clear. And our a should not be equal to 0. So let's write this in this form. So that is, this is going to give us 1 over, into brackets, a over b to the power n. Okay. Now we can also put this as 1 divided by, into brackets, b over, a over b to the power n. Okay. Now, per the rule that we need in dividing fraction or multiplying fraction. So this remains 1, and then we change this to multiplication and turn this upside down. So that is going to be b over a to the power n. And 1 times anything is the same thing. So b over a becomes to the power n. And therefore a over b raised to the power negative n becomes b over a to the power positive n. Okay, now let's solve some few examples to this. Okay, now let's look at this example. Simplify 1 over 2 to the power 4 times 1 over 2 to the power 3, then over 1 over 2 times 1 over 2 to the power 5. Okay, so let me write everything here. So that is going to be 1 over 2 raised to the power 4 times 1 over 2 raised to the power 3 divided by 1 over 2 times 1 over 2 raised to the power 5. Okay, now per this, they have the same base and we are multiplying. So we just write, you add powers. So 4 plus 3 over, the same thing applies to this, they have the same base and multiplying. So this is 1 over 2, then to the power 1 plus 5. Okay, so that becomes 1 over 2 raised to the power 7 divided by 1 over 2 raised to the power 6. They have the same base dividing, so we subtract powers. So this is 1 over 2 to the power 7 minus 6. And the answer is 1 over 2 to the power 1. So it's the same as 1 over 2. Okay, let's take another example. Okay, so looking at the nature of this, let me write the question 2 to the power 2 all to the power 3 times 8 to the power 1/3 times 2 to the power 2 divided by 16 times 2 to the power 3 times 1 over 4. This is like the third law of indices. So the powers will multiply. So that is going to be 2 to the power 3 times 2, 6. Then times, we can also put 8 as to the power 3. So that is going to be, so let me maintain this for now. So 2 to the power 2 all to the power 3. Okay, so we can change this to be 2 to the power 3 all to the power 1 over 3. So that is the 1 over 3 is there already. Then 2 to the power 3 is 8 times 2 to the power 2, then all over 16 is also 2 to the power 4 times 2 to the power 3 times, and 4 is 2 to the power 2. So we can say 1 over 2 to the power 2. Okay, so now let me continue from here. So this is going to give me 2 to the power 6 times, this is 3 over 3. So that is 2 to the power 1, because this will take care of this one. Then times 2 to the power 2 divided by 2 to the power 4 times 2 to the power 3, then times 2 to the power negative 2. Hope we've recalled that. Okay, now this is going to give us, they are multiplying, they are of the same base. So 2 to the power 6 plus 1 plus 2 divided by 2 to the power 4 plus 3 minus 2. That is, they are multiplied, they are of the same base. So this subsequently becomes 2 to the power 6, 7, 9. So 9 divided by 2 to the power 7 minus 2, so 5. And this is, they are of the same base divided, so we subtract powers. So that is 2 to the power 9 minus 5, and that becomes 2 to the power 4. Okay. Please, thanks for watching, and we'll meet in the next lesson. The name has always been Odum Maths on YouTube, Emmanuel Odum on Facebook, and on TikTok, odum.maths. Thanks for watching. Bye.